This is an example of how to solve a multi-step equation. Again, multi-step just means more than one step. And when you solve an equation, you're always going to be using the order of operations backwards, or in the opposite order. So the first thing we're always going to do is we're going to try and identify what's being done to our variable. And in this case, our variable is x. And what are we doing to x? Well, you can see over here, the 2 is multiplying x. So we know we have multiplication. And we can see over here, we're adding 1 to x. Okay, so if we were following the order of operations, clearly we would multiply first, and then we would add. So in this case, to solve this equation, we're going to undo adding first, and then undo multiplying. So I'm just going to rewrite it over here, make it a little cleaner. 2x plus 1 is equal to 7. So in order to undo adding 1, we would subtract 1 from both sides of the equation. Leaves us with 2x over here is going to be equal to 6. And now, if you look, we basically have a one-step equation left. And we're going to solve this part of the equation by undoing multiplying by 2. And the way you undo multiplying by 2 is you divide by 2. So I'm going to divide both sides of the equation by 2. And that's going to give me x is equal to 3. And then, as we always like to do, I'm just going to make some room here, we like to actually do our check to make sure that we did solve the equation correctly. So the check is going to go to the right side, write the original problem, and then we're going to substitute in what we think the answer is, which in this case x is equal to 3. We're going to substitute that in for x. So 2 times 3, remember always substituting in parentheses, and then we're going to solve this using order of operations. So we have 2 times 3 is 6, plus 1 is 7, and then 7 is equal to 7. And the problem does check. We can verify that 7 in fact equals 7, so we know that we solved the problem correctly. Another example of a multi-step equation, and I'm going to show you both ways to solve this problem. The first thing that we would do when we look at this, we would naturally assume to use distributive property, which, again, is one way to solve the problem. So we're going to distribute the negative 3. And again, I'm going to include the extra step. You don't need to put this particular line in. But it's saying that negative 3 times 2n plus negative 3 times 1 is equal to 24. And negative 3 times 2n is going to give me negative 6n. Negative 3 times 1 is going to give me negative 3. And that's going to equal 24. Now, in order to solve this, I basically have to undo adding negative 3. So I could do that by subtracting negative 3, or just by adding positive 3. Because if I add positive 3, you should know at this point that negative 3 and positive 3 are additive inverses. So they're just going to drop out of our problem. And this is going to equal 27 on this side, and I bring down my negative 6n. And then I would divide both sides of the equation by negative 6, because at this point, all I have left is multiplication in my problem. So I'll divide both sides by negative 6, and that's going to tell me that n is equal to, and if I just reduce that down, hopefully you can see that 3 goes into both of those numbers, I'm going to end up with negative 9/2. And that is one way to solve the problem. Now, like I said before, there is a second way to solve the problem, and I'm going to see if I can show that to you right now. I'm just going to move this over a little bit. Okay, so our original problem was negative 3 times 2n plus 1 is equal to 24. So the other way that you solve this problem is you can see that I'm multiplying my negative 3 times something. So I want to treat that something as though it's its own variable. So I'm going to say it's negative 3 times blob. And in order to undo multiplying negative 3 times blob, I would divide both sides by negative 3. So my negative 3's over here will cancel, and I'm left with that blob, whatever was left there. which is 2n plus 1, and that's going to equal negative 8. If we look at this problem, again, I don't need the parentheses around the 2n plus 1 because I got rid of the negative 3. There's nothing that's multiplying that 2n plus 1 at this point. So I don't really need those. I'm just going to move them out of the way. But now I'm ready to solve my equation just like I had before. So I will subtract 1 from both sides. And I have 2n is going to be equal to negative 9. And then if I divide both sides by 2, you can see that n is going to be equal to negative 9/2, which is the same thing I got before. So you can see when you have a distributive property problem, you can do it multiple ways. Whichever way you do it is entirely up to you. Both ways are perfectly acceptable. Your choice.